Okay, so question 12 is a time and work question. It's a theta, so if you're good at it, you should look at it, otherwise, probably not. Let's see what is happening. A reputed company has some skilled employees. They can complete a project in 11 days. We don't know the number of employees, but the company removes 4 employees every alternate day starting from the third day and include 3 new employees every alternate day starting from the fourth day. All removals are done at the end of the day. In this way, the work gets completed on time and no worker is left at the end of the last day. The work gets completed in 21 days. Okay, so let's see what happens. Let's say the total number of employees at the beginning are X. So if you take the number of people as X, then the total work is 11 into X when nobody's been removed. So this should be equal to first day, X people are working. Second day, X people are working. Third day also X people are working because the removal on the third day is done at the end of the day. So for the next day, 4 people are removed. So third day end, 4 people are removed. So third day is worked by X people. The next day, X minus 4 people will be working. And 3 people are added at the end of the day. All removals are done. So I'm assuming that the additions are also done at the end of the day. So this is X minus 4 plus 3. So this is X minus 1. So the next day will become X minus 1. And so on. This is the pattern. Right? So this is what is happening, and this is going on till 21 days. And on the last day, at the end of the day, nobody is left. At the end of the day, nobody is left. So this 11x should be equal to, please keep in mind here, removals are done at the end of the day. The additions also I'm taking at the end of the day. So this should be equal to, so this 3x if you take up. Now the remaining will form a pattern, x minus 4 plus x minus 1. Then x minus 5 because 4 will be removed on this day, and here plus 3 will be added, so this is x minus 2 and so on. Now 3 days are already here, this is 3 days, so send it over here, so this becomes 8x is equal to, now the remaining days, total 21 days, out of which 3 days I'm already taking to the left hand side, which means the remaining is 18 days. So I have a series of x minus 4, x minus 1, x minus 5, x minus 2 up to 18 terms. You can clearly see that there will be 9 even terms, 9 odd terms, and the series will be ending with a even term. Ending with even term. So what are the even terms? This is an even term. This is an even term. So even terms pattern is x minus 1, x minus 2, x minus 3. This is the pattern I want. 9 days, 9 terms. So clearly the last day will be x minus 9. So x minus 9 people are working on the last day and the work gets completed, and at the end of the day there will be 4 people removed, and after removal of the 4 people the total should be 0, which means x minus 13 should be equal to 0. I hope you get the logic here. X minus 9 worked on that day, right? So to go to the next day, or at what happens on the day, on the even termed day, 4 people will be removed. Always notice here minus 4 is removed, that's why you get x minus 5. Here minus 4 will be removed, that's how you'll be getting the next term as x minus 6, which is the odd term. So on x minus 9, the eventh term day, x minus 9, 4 people will be removed. So at the end of the day, totally will be x minus 13, but that is 0. So my x should be equal to 13. X should be equal to 13. So you don't need too much of calculation here. If you analyze this, you can get the answer quickly. But yeah, you could probably have to write a couple of series, but it looks intimidating, but it can be solved if you just keep your cool and look at it. But this is a trap here. I mean, since it's a theta, many of the students might miss and say even if they got till here, they could have written 9 and that would be the wrong answer.